Hello, my name is Professor Victor Cheng. I'm very honored to give a talk that's regarding to one of our published paper on healthcare analytics. The title is called An Artificial Intelligence Model for Heart Disease Detection Using Machine Learning Algorithms. So I'm going to talk about the paper with introduction, briefly on literature review, on the methodology, results, analysis, conclusion, and lessons learned. At the beginning, we know that there are many diseases. So this talk is on heart disease. So heart diseases are normally due to the cardiovascular diseases, which means that it refers to a condition of the block or narrow blood vessels resulting in a stroke, chest pain, or angina, and a heart attack. So our blood vessel, because of the blockage or because it narrows down and it causes problems to the heart, and the heart needs to pump with more forces and to pump more blood. So other kind of heart conditions that may have the problems with rhythm, valve, or the muscle, or the heart are the other types of heart diseases. However, there are different types of technologies, and machine learning can help us to understand what happened and to make a very good forecasting. And then they will be useful for doctors to gain the knowledge about the insights, and also to help them with better decisions in terms of treatments and then recommendation to the patient. The heart disease is mainly due to the incorrect symptom of a coronary artery disease. It is also known as cardiac disease. So because they are due to various factors and possible few reasons, and it's not an easy thing. And therefore, it's very important, as you can see that in this system, it tells you and tells us how we are going to perform the entire work. So we have the medical database with the patient's record, and we have to perform data pre-processing, and it will then text us with different types of methodology. And usually there are more than one type of model to make a better analysis, and then with the prediction, so that will help the doctors with the decision. And also the talk is for people who do not know about Python or machine learning that much. So they want to know how machine learning and also Python that will be useful for healthcare and other applications. So as we know that Python is object-oriented high-level programming language that has been have a very rapid rise due to the popularity of applied AI in data science. And there are also a lot of people learning about this. In the healthcare sector is also growing the popularity, and at least 32% of UK individuals that have learned about this language, and it will be very useful for healthcare, and there may be even a higher proportion now. And it's also considered something useful, especially you can work with AI-based software development and also other web applications. So the Python framework can be very easily used for creating a desktop or web-based application. And the application of Python programming in healthcare sectors, especially for detecting heart diseases, clinicians and institutions can provide better and improved outcomes of the patients through scalable and dynamic application, even with the apps and with all the software as a service to help them with a better decision and diagnosis. And the coding packages and libraries used in various types of Python, such as Pandas, Matplotlib, IPython, NumPy, Python, and SciPy, and many others are available. And the healthcare sector is generating lots of information and from several facility and patient. By applying the best usage of this data, doctors can anticipate with superior methods of treatment and enhance the complete delivery system of the healthcare sectors. And as we know that the coronary artery disease is very common type of the heart disease that happens when rising with the bad cholesterol. In early stages, the cat had no symptoms. When plaque gets large enough to block the blood flow, the patients can feel the symptoms such as chest pain, shortness of breath, and fatigue. So at the beginning, it's very hard to detect, but then once the vessel gets blockage or gets narrow, and then you begin the pain, and you can feel that the painfulness is with a steep rise. Therefore, we need a more and better system to detect that with a higher accuracy, and also they will help us to be able to give the treatment on time. The Python language can be useful for the Health Insurance Portability and Accountability Act, because that it can deal with the information easily, and it works with other healthcare platforms. And then it's also considered as a very suitable language, because you can build in the tools that can complete with the data integration and security. And the healthcare sectors have a rising use of Python, of course, that due to the popularity in terms of analyzing the data. And then in order to meet those demands, we have 4 research objectives. First of all, we need to critically analyze the ways that Python language is used to detect heart disease. Second, we can critically investigate the previous activities and apply a suitable methodology approach for superscribing the identified problem. Third, we can critically apply data interpretation strategies in Python language for healthcare problem detection. Last, we can critically assess the artifact or protect with the help of cybersecurity approaches using appropriate methods and identifying the limitations and strength of the work. So we then provide better analysis and also help with the cybersecurity. So in terms of literature review, the major causes of heart diseases are diabetes, obesity, unhealthy diets, overweight, excessive alcohol use, as well as the physical inactivity. Therefore, heart disease includes the arrhythmia that is considered as the heart rhythm abnormality, and also with the problem with the cholesterol that's making the blood arteries with hardening and with narrowness. So due to the unhealthy diet that will lead to obesity and so on, it will then make the case much worse. And some people have those symptoms during a heart attack. Along with that, the pain also spread to arms and other parts of the body. Then they may make the patients feel very dizzy or lightheaded with the throat or soreness, also snoring and sweating. Also, people age 65 and older are usually more likely than younger people to suffer from a heart attack, to have a stroke, or to develop a coronary heart disease. It's called a heart disease and heart failure. And many algorithms, such as the hybrid methods, are used in conjunction with logistic regression, naive Bayes, k-nearest neighbor neural networks to integrate with heart disease diagnostic algorithms. As you can see, that there are different ways to analyze, and then we usually use a number of different machine learning algorithms to help us, because we do not want to miss any important data, and we want to give a more wider spectrum so that we can then have a better understanding of the possible causes. And in terms of data and methodology, first of all, this paper will then show how the program works. And in fact, we even put a code at the end of our paper. So if you can, please go to the website and read our paper and consider citing. And the system uses a dataset comprising 14 characteristics of the test outcomes, carry on around 100 people, and the dataset has a name called state log part. But however, it has been not available from the public domain. So we were very fortunate to get a dataset before it was available. But please know that for the data ownership, the authority have the right. So in this case, that based on our analysis, the patient suffering from the heart disease symptom will be diagnosed using binary digit 1 and 0. 1 will indicate the true value. That means that the patient is suffering from the heart disease. 0 then indicates the false value, which means that the patient is not suffering from any type of heart disease. So we then have to understand the correlation and trends of the obtained features will also be recognized with the help of several features, such as the gender, the age, the CP, the stand for chest pain type, code, that means that cholesterol level, FBS, that stand for fasting blood sugar level, is zinc, that stand for exercise-induced angina, and also THALEC, that stand for maximum achieved heart rate, OPIC, ST, depression persuaded by exercise repetitive to rest. Dial that stand for maximum achieved heart rate, and CA that stand for the number of major vessels. So we then have to record all the key variables, and those patients have been carefully followed. So even they have been taken key indices on a regular basis. So then they will measure about the cholesterol, and even have fasting will understand all the impacts to the heart disease, and also understand what's the maximum heart rate and what will be the achieved things that need to be done, and so on. So for the research, what our contribution mainly is to analyze the data. So we first of all, we can then import the data easily. So we can use the libraries as NumPy and also Penta, and then we can load the data set. So the CSV file is usually the kind of data set we're talking about, and it can be loaded into the system very easily. And you can then begin to read and pre-process the data. And then we have the exploratory data analysis that stands for EDA. So EDA is used to get a better understanding of data and look for the data. So it's a kind of discovery of the trends and observations within the data using visual methods. Along with that, the EDA is frequently used as the first step in the data modeling process. It follows handling missing value, outlier treatment, encoding categorical variables, and normalizing, and finally scaling and removing duplicates. Of course, it's usually the step that we perform just to have a basic understanding about data, and then to find any normal observations, so that we can then make the first few steps to improve the quality of data before our analysis. Correlation metrics will be used for evaluating the connections within several types of the variables. It sums up power and direction of a linear relationship between two variables. It allows values between -1 as well as +1. This represents an excellent way to check correlations among features by visualizing the correlation matrix as a heat map. So we want to know between variables whether they are related or not. This is crucial, especially we want to know the possible reasons for having the heart attack. Of course, everybody is different, but then if collectively there are a lot of people that have the heart attack due to same or several or one or two factors, then it will be very meaningful for the research. So then we can then look at the process. We start with that. We put into the system with a CSV file, and then of course the database will keep updating, and then we put into the Python platform, and then we can ensure whether there's anything missing. If yes, then we then check. We can get the missing data back, and if everything works perfectly, then we begin to analyze the data set. And then we can then split the data set into a trained data and a test data that can be in a different proportion according to your need. And then we then use the proposed model or the proposed algorithm to perform the analysis. And then we can use the accuracy score as a mean or as a way to identify the overall outcome. And the training and testing, the data set is split into the trained data and test data. The training set is then equipped with a random forest algorithm, and the test result is predicted. And the split can be between 80% to 20% or 70 to 30%, and sometimes 75 to 25%. But research we normally will go for 80 to 20%. Then random forest together with other machine learning algorithm. But we actually, before doing this, we have tested several algorithms, and then random forest is the one that have better or even best performance among other available algorithms. Therefore, we then use that as a way to get the overall accuracy. And the performance evaluation confusion matrix is also used for generating false positive and negative outcomes. The metrics used to evaluate an algorithm are accuracy, confusion matrix, precision recall, F1 value. So that we need a number of different results to show the validity and reliability of our analysis. So through the implementation of the confusion matrix, the accuracy is printed as well as displayed on the screen. Then talking about the security, because that's very important. Then before we do any analysis, first of all we have to be compliant with GDPR. We need to ensure that we have carry on the research in the secure environment. So it's very useful that we double check whether we are having the following the recommended steps, so such as the encoding, sending back packets, network scanning, port scanning, accessing servers, discovering hosts, analyzing malware. It is also useful to conduct a stream of cybersecurity application, such as malware analysis and scanning. We want to ensure that during our analysis, we do not leak any data out, but we have to ensure that everything is kept at a very top level of security. And the healthcare sector comprises of huge amount of confidential information of patients. This language is well suited for developing application within this sector, because we can then write other applications to support or enhance the level of security, whether network security, whether data security, or whether encryption. However, the availability of huge number of libraries and also decreases the amount of effort required to conduct specific tasks, such as cyber threat analysis, detection, penetration testing, and so on. Because there are also other existing libraries we can make use. So usually, if you develop a healthcare application, it's also quite often that you may also develop additional security apps or security functions. And it's not that difficult, because once you get understanding about the libraries, then you can make use of it. However, you can also develop your own algorithms if that is what you think additional feature will help. And this will be a series of recommended steps you can follow. Then now we are talking about machine learning algorithm. I have already given detail in other talks. However, I think the most important thing is to capture the important thing. So neighbors classifier, usually we use this such as the neighbors majority vote is being used, and we want to find, let's say there are a few data points, they are very close to each other, and we want to find where is the one that will have a final data point that would be the nearest one. So then we can calculate this also mathematically. And then with machine learning algorithm, we can then find the k-neighbors classifier very easily. Support vector machines, SVM, has been used commonly in machine learning algorithm, and such as regression, such as other specific needs. SVM simplifies the coordinates of separate observation. The SVM classifier is considered as a frontier that best segregates the two classes. The output is considered as the accuracy value of the SVM model that inputs the parameters of the X trend as well as the Y trend in a method of a fit predicate. So X trend stands for the coordinate for the X-axis, and the Y trend stands for the coordinate on the Y-axis. So the data are being plotted, and then usually we use this command, then we can then easily plot the graph. And then we also have another similar command that's called a score predicate, that is useful to give a score of the model of the input parameters for X test and also Y test. And then we can then use the score for the SVM model easily. We can also look at logistic regression, because it's useful for classification algorithm. The target variable is dependent on the categorical method that is used. The variables of the logistic regression show the class. The class is a variable of the categorical dependency. The logistic regression involves the logistic function that the model is the dependent variable. It is considered as a supervised learning classification algorithm that is used to predict the probability of a target variable. Then decision tree classifier is used quite commonly in heart disease detection. You can look at this diagram, because usually the algorithm will then calculate the possibility, and then each one, the leaf node is usually the final outcome, and then you will then compute with the probability. So that because first of all, we need to know some other possible reasons, and then based on the health conditions, and then the algorithm will then calculate what is the most likely probability based on the patient's case, and then it's used as a visual component that classify the data items. The output is accuracy value and the decision tree of a model by inputting the parameters of the X trend as well as the Y trend in the method called fit predicate. And it discovers the score of the model input parameters of X test, Y test into the method score predicate for searching the score of the decision tree model. So then we can calculate the model easily. The algorithm is considered as a flowchart, such as the tree structure, as you can see like here. And it has an internal node that displays outcomes and branches that constitutes the decision tree, where every leaf of the node constitutes the outcome. So as you see that this is the final outcome. The top node is known as the root nodes of the decision tree algorithm. And random forest algorithm has been used, and we use that for classification and regression. It is classification of heart disease detection algorithm works by constructing multiple decision trees. So we have multiple decision trees that will work for us, and in a way that will give a better output. However, random forest and decision tree still have a little bit of differences, because random forest, you can use the US presidential election as a kind of analogy. So let's say in this state, the majority win, and then after that you then find out which final cluster belongs to the final winner, and then count the final winners of the cluster, of each cluster. So this classifier uses a technical bootstrap aggregation. The feature significance is calculated as the disease in node, impurity weighted by the probability of the reaching the node. And the SCI kits learn, or sklearn, calculate the importance of nodes using Gini importance and assuming only 2 child nodes are being available. As you can see, there are mathematical formulas here. So then, due to this reason, the final output is the random forest algorithm based on several multiple decision trees. And the implementation using Python. And because now the talk is for those who are beginners, it's not for those who are using advanced algorithms or developing completely different and also completely new on your own. But if let's say you use existing function, what will you do? First of all, you then import the CSV file and use the existing library, and then after that you can use a matplotlib. Then you then create charts. So you want to see some of the visual outputs. So you can use pyplot. So you import the data set, use the _CSV that reads the data set as well as save it to the data set variable. And then we use the data frame.info predicate function to get a concise summary of the data frame, and it comes with efficiency when doing the exploratory data analysis. It gets a quick overview of the data set that uses this command, data frame.info predicate function. The pandas describe predicate is used to view some basic statistical descriptions, such as the percentile, mean, standard deviation, and many more. So it will give an overview about the data set. So usually you can use some simple command that can show you an important summary. And we can use a correlation matrix and understand data.pyplot to show the correlation matrix using the x-ticks as well as the y-ticks.colorbar predicate. So that means that it displays the color bar of the matrix, and split the data set into the training and testing data. Then we training set should be fitted to the random forest algorithm. To make it fit, we then use random forest classifier class from the sklearn assembly library. So this is a kind of code. So you can see regressor is equal to random forest regression predicate n underscore estimators equal to 20, random underscore state equal to 0. And then you start the initialization. N underscore estimator is the parameter in the random forest classifier class. The number of the trees in our random forest is determined by this parameter. Of course, if you want to do more random forest, you can then set the estimator to have more numbers. However, it's going to take you slightly longer time. After the model is built, it is trained on the training set by using regressor.fit predicate x underscore train y underscore train, and used to conduct a prediction by using y underscore predict equal to regressor.predict x underscore test. The results are outputs by using the functions confusion underscore matrix the Y underscore test, Y underscore pre, and also classification underscore report, Y underscore test, and Y underscore pre, and from the sklearn library. Of course, there are slightly different variation from different platforms, but it's very important you understand what you're trying to do. Once you keep the logic right, it really doesn't matter what the commands are. Sometimes it's just like you are treating it as learning a new foreign language. You know, every item has a very specific name. It's just that you need to know what you're trying to do. And usually those commands are very straightforward. It's very related to everyday English. And then you put in the right parameters and then begin to process the data. And then the data interpretation is a crucial step because it's not very useful if you do not know what you're trying to do. So data manipulation or data interpretation is a process of data transformation, formatting, as well as structuring. Apart from this, the matplotlib library is used for plotting as well as visualizing the data. This library allows plot graphs, heat maps, line plots, histogram, as well as a lot more. It is embedded in GUI toolkit, so that it gives us a very good overview and also the summary about what the data is and about how each variable is all about in terms of distribution. If, let's say, we put a histogram and then we then know in terms of the age of the patient, how does it look like in terms of this variable, this group of variable, let's say we're measuring cholesterol, how everybody is measuring against to. So this output represents a histogram of the data set of heart diseases and also heart disease detection. It is used to summarize the discrete data and it provides a visual interpretation. This requires focusing on the main points, facts, and the numerical data by showing the number of data points that falls within a specified range of value. So then we can have a very good understanding about what the data set is all about in terms of how the patient's overall outputs are, in terms of how the variable then interpret the patients. And then you will also help us to focus a lot more. Let's say if there are more people fall into this area or this area, then we can pay more attention to it. The exploratory data analysis allows the data analysis that excludes the statistical methods as well as interferences. This data consists of 304 records with 14 attributes. So as we have explained earlier, they will include age, sex, cholesterol, and also fasting, and also how you react to the maximum heart rate, and so on. So I think all the key variable will have to be presented and analyzed. And of course, that we can then use the bar graph because that it shows a very good counterplot to represent the target variable of the data sets. You can see on the right-hand side, and the patient suffering from the heart disease, so we can know how many of them are suffering. So there are more suffering from that. And these are other things not caused by any heart disease, but sometimes you may have similar symptoms, but due to different reasons. Then we can then use the code, let's say the SNS dot set underscore style, and also with the SNS dot count plot. So then we can then understand whether how the data looks like, and then also a positive correlation will be crucial because that can exist between the predictor and the chest pain variable, indicating that the amount of the chest pain is directly proportional to the probability of suffering from heart disease. Then we need to know the variable, whether which one is dependent or which one has a more impact, or maybe is having a higher percentage of probability. The chest pain, in this case, is considered to be a static feature with 4 variables, namely value 1 to 4. And that refers to different meanings of angina, because even for angina, which means that you feel a problem with your heart, it can be due to various reasons. So then we in order to make a better classification, we want to make sure that each one is due to a very specific reason for it. A negative correlation among these variables will indicate that more amount of blood is required by the heart. And what is interesting is that through this heat map, we find that there is a negative correlation, which means that certain things that cause you with the chest pain, with a heart attack, or maybe you feel extremely very painful in your heart was because the heart need to pump with more force, and sometimes because of the narrow or block vessels and the speed in which the blood that comes back to your body and to your heart is slower. Therefore, there's not so much blood, and with not so much blood, the heart need to pump harder again, and it gets into knock-on effect or vicious circle. So in a way that it was because certain part of your body is not reacting, is the heart is working extremely hard without any resting. Even when we are sleeping, the heart is still working. It's just pumping at a slower pace. But then it's very interesting that we need to know how the variables are related, and therefore the random forest, in this case, is focused, let's say, on patients' medical history such as sugar level, blood pressure, chest pain, age, and gender based on a given scenario. Then we make a better analysis, and also we have to look at all the patients' case, and we get an accuracy based on what is 100 patients, we get 83% overall accuracy. Although you may feel it is as high as 90+%, but then think about this. We want to make sure that in our analysis, we want to ensure every major factor being found, and also the correlation between them. We don't want to just aim for even 99% accuracy, but then miss any key variables or even any correlation, because there could be some other researchers, they only focus on very high percentage of result, but then they probably have not been looking at what caused the problem. And then it is more meaningful in our interpretation that we find if we can find any hidden errors. We want to make sure that we do things step by step, and then eventually, if we do not make any mistake, then we can improve on accuracy. So the conclusion is that the machine learning has performed a significant role in creating accuracy as well as determining results with the aid of training data. According to the scenario, it can be highlighted that the selection of a random forest classification is developed based on the exact data set and decision tree. In our research, the highlight is on data analysis, works with categorical variable. Along with that, it will also break particular categorical columns into dummy columns with ones and zeros. Apart from this, the data output of this application is used for many medical parameters such as the age, sex, blood pressure, cholesterol, as well as obesity for prediction and requirement of the software which is used in the development application, because we need to ensure that the data has a good quality before analysis, but we also want to ensure that we analyze every single factor, and then by looking at all these, we then get to a good percentage of accuracy as explained. In the next paragraph, the machine learning algorithm and application using Python will be the subset of the model for AI, and also the Python libraries are the prerequisite for making predictions. So we can use sklearn, and also there are similar other platforms there. There are also people using TensorFlow, and some people even use both. But then we give the 83% accuracy given by the random forest. But then the thing is that we have multiple decision tree running for this, but we also run every single variable. We also want to ensure that the variable works well, and we do not miss anything. And then after that, we may even think about better outcomes and even a better prediction for the next level. So in our vision for future development, because for research, we also feel that it's important to give some of our visionary thoughts. So first, digital healthcare services and apps will be common and available. We may have to come across them more and more often. Second, this research will only demonstrate a possible way to do it. Then it is important you know about the process and other available methods, and not just about the data set, because a lot of people, they just focus, oh, where is the data? Or without the data, we cannot do the research. But sometimes it's about you build a process, you build the things well. So the data set is only to help us to acquire our goals quicker. Without a data set, if we, let's say, you build a process well, and if there will be a similar opportunity, you can then finish the research with a better output and quality. The machine learning and also the data analytics help transferable techniques and skills, because if you are able to do this, you may be able to transfer those skills in a different setting, different project, or even a different domain. It is not just Python, but there will be more similar tools, languages, apps to make development easier. There will be other ways. Of course, there are people claim that you can use ChatGPT. However, ChatGPT maybe just give you some general idea. You still have to make them work. And there will be probably for future research as well. We should have an open mind to learn new things and keep our skill up to date. And the next thing is that why should you cite a paper? There are 5 reasons we feel that. First, the intelligence system can lead to selective proper treatment methods for patients with heart disease. So we have shown that this is one way of doing it. Second, data mining is a better approach for predicting heart disease that helps to decide the line of the diagnosis to be followed by extraction from the appropriate dataset. Using random forest algorithm, our research with Python helps to detect heart diseases among the patients. So our work support the real-world solution. Therefore, it will help to resolve part of a problem. The data interpretation strategy is applied in this application of heart disease detection, along with the findings that can be interpreted for achieving rationale as well as the logical argument. The artifact of this application will assist in evaluating the third party with the assistance of the appropriate method. So the third reason is that we also support the healthcare research, and we demonstrate that it works for the healthcare in terms of heart disease detection and prediction. Fourth, this paper discusses the importance of strict application of network security technologies to ensure compliance with network configuration and information security management system in the healthcare sector. So we show the example before we do any analysis, we have checked and enhance the network security, data security, and also the information security. And so, last, behind the scene, and since in the past few years, the team and the principal investigator have helped many students acquire new skills and apply them in their studies, research and jobs, and also in other settings, in other domains, in other projects, not just in healthcare. But we would like to ensure that our research outcomes are impactful and are meaningful and helping others with evidence. And if you can, please go to this link and then read our paper and then cite our paper. Consider citing our paper. So far, our paper is the one probably or the most downloaded paper and also the most cited paper on this journal. But we hope that there will be more citations based on the work that will be helpful, relevant, or inspiring to you. Thank you so much, and we wish you all the best.